Hello everybody, and welcome to this final class on logic. We are going to cover a few more topics today, and then we will have a small quiz to, check ourselves on the knowledge and make sure we don't forget any of the concepts. So I'm actually going to start by discussing this thing that I had given as a problem for the startup puzzle that I always give. So here, the thing that I gave was to test the validity of this particular statement, which says that this sentence is false. It's a very famous paradox. It's always called the liar's paradox. You can look it up on Wikipedia. So it doesn't really have an answer. The thing about the problem is, if it's true, it's a problem, and if it's false, it's also a problem. So it's called a paradox. It's one of the very famous paradoxes, and we'll talk more about them later on in the discussion if people are interested. So why this doesn't have a valid answer is, suppose the statement is actually true. So if the statement is true, then it would mean that it is false, because the statement itself is saying that it is false. But if the statement is actually false, then it would be true because it is saying that it is false. So then it gets into a never-ending loop. So we can never actually conclude whether it's actually true or false. So it's called an invalid statement. It's not valid, and it's logically incorrect. And the reason that it's logically incorrect is because it is using the definition of itself inside itself. Because it is talking about a sentence being false while it itself is a sentence. That's similar to the question which Shreyan asked last week. I don't know how many of you were there in the discussion session. So he asked about is it possible to have a set which will contain all possible sets, right? So that's a very famous, it's a Bertrand Russell paradox. So the question goes, can we have a set, a mathematical object, right? A collection of objects such that it will hold inside all the possible sets. It's like, can you have a bag which will contain all the bags in the world? So technically you cannot, because the question is, will the set itself be inside it? And then if it is also going to be inside it, then we need to create a bigger set, because then now we have a new set which is not actually inside the set. So it kind of creates a never-ending paradox. And the situation is very similar to this one, because we are using the definition of an object being a set inside itself. So it's similar to saying, how many dimensions are there in the universe? Where will you ever stop? Because you say that every dimension should be contained inside another dimension. So then inductively it leads to an infinite set of events. So it's more like induction. I'm sure most of you know induction. Because if you prove for the base case and the next one, it just keeps on going. So every set will keep being added to this huge set, with itself being added multiple number of times inside itself. Okay, so that is how these paradoxes happen. And now let's move on to this type of arguments. And now we are going to only go one at a time. We're not going to look at the other ones. So you might recollect that in the last class, I spoke about an argument being a valid argument and an invalid argument, right? And I gave an example that when you sometimes have a debate with somebody, or if you're reading an article, or if you're trying to do research and you're collecting data, you need to make sure that the approach that you use is actually correct and credible, because otherwise nobody will believe you. So here is a supposedly logical argument, and then we have to decide whether it is logical or not. And we're going to use the same things that we studied in the previous class. So we're going to talk about implication, we're going to talk about negation, we're going to talk about or, and all those things, which are not that difficult to understand. But let's actually look at an example. So there are two sentences and there's a conclusion. The sentence says, all crows are black. Remember, there's a small disclaimer that I want to give you. We are only discussing about the validity of the argument. We don't care if the argument is actually making sense or not. It's just, is it logically correct? Because I could change this argument to be all crows are blue, and it should still work, if at all. Okay? So it's nothing to do with the color black. It's just to do with the structure of the argument. So all crows are black. John is black. Therefore, John is a crow. This is the statement. All crows are black. John is black. Therefore, John is a crow. Now, at first sight, it might look correct. But if you look at it closely, you'll realize that it's an invalid argument. For the simple reason that we might have said that all crows are black, but we didn't say that anything in the universe that is black is a crow. So in fact, in this case, it's not only a valid argument, it also makes some sort of realistic sense. So all crows are black and John is black, but well, John need not be a crow, right? Because there could be a lake that is black, there could be a stone that is black, there could be somebody's hair that is black, but we just know that all crows are black. So, but we can infer from this though, we can infer from this that if something is not black, then it will not be a crow. That's something we can understand from this. So all crows are black, and then we find some object in the world which is not black, then it cannot be a crow because all crows have to be black. So if you find a pink object, then that object will not be a crow, right? That's what it means. Okay, so that's there. Let's go to the next one. The same argument, but there's a slight change in it. It says only crows are black. Now we are going to only speak logically. This doesn't make sense in the real world because we know for a fact that this book here is black. But I mean, the argument says that only crows are black. Nothing else in the world is black. Then it says John is black. Is John a crow? In this case, yes, this argument is extremely valid. And it's fully true because the only thing that is black in the whole world you're saying is crow. And you're saying that John is black. So John has to be a crow. Because we just said in the first sentence that only crows are black, which technically means that there is no object in the world which is black and is not a crow. I think you're getting the sense of this. So the reason I'm giving this is because some of the questions in the quiz are similar to this. So I just want to give you some sort of a trailer. And now the last one, a very, very interesting one. So all Democrats always tell the truth. Okay, all Democrats always tell the truth. President Obama is a Democrat. So President Obama always tells the truth. Think about this. All Democrats always tell the truth. President Obama is a Democrat. So President Obama always tells the truth. Well, what do you guys think? Valid. Very good. So this is a valid argument because we say that anybody who is a Democrat will tell the truth. So all Democrats always tell the truth means that any person who is a Democrat will speak the truth. And then you're saying that President Obama is a Democrat. So then President Obama has to tell the truth. There's one more argument that I want to share. This is just something that I remembered. It's a famous paradox. In fact, let's investigate if it's a paradox or not, because I don't think it's a paradox, but it can look like a paradox. Socrates, that's not Socrates, it's a Euclid. Euclid said all mathematicians are liars. Euclid was a mathematician. Now this is, we are not talking about validity or anything here. We are just trying to think about this particular argument and see if it makes sense. Euclid said all mathematics, by the way, he didn't say this, okay? Sorry, Euclid, this is just an example. Euclid said all mathematicians are liars. And Euclid himself was a mathematician. So what happens to his claim? Think about this. Yeah, some people are messaging me saying that they weren't able to hear something. Maybe they joined a little late, but don't worry, the recording will be posted soon. So let's everything is cool. You can watch from wherever you want to. So Euclid said all mathematicians are liars, and Euclid himself was a mathematician. Okay, so let's try to discuss about this, right? The first thing we want to say is what is known here. Like, what is something here which we can be certain about? We can be certain about the fact that Euclid is a mathematician. So that's a given statement. There's nothing to think about. Now the thing that we're thinking about is he telling the truth or not? And then depending on that, we are trying to come up with a conclusion. Now, Euclid cannot have been telling the truth. He cannot be a truth teller because he's saying that all mathematicians are liars. So if we say that Euclid is a truth teller, then it would mean that the statement, all mathematicians are liars, is a true statement. But then that's technically not possible because Euclid himself is a mathematician. So Euclid cannot be a truth teller. Are you understanding it? Because if he's a truth teller, then everything that he says has to be true, which means this sentence should also be true. But that sentence is saying that all mathematicians are liars, which would make him a liar. So that sentence cannot be true if he is telling the truth. The second investigation is if Euclid is a liar. Now, Euclid is a liar, which means whatever he said is a lie, basically. He is a lie, not could be, it is a lie. And the statement that he makes is that all mathematicians are liars. So that is more believable, because the statement that all mathematicians are liars is wrong. Let us say that there are some mathematicians who are truth tellers and some of them who are liars. Euclid happens to be a liar, so he's making this wrong statement. So the thing is that Euclid was a liar, and then everything is making sense. Now let's try to change it a little bit. Let's say Euclid says some mathematicians are liars. Euclid was a mathematician. Now Euclid could be telling the truth, because he's just saying that some mathematicians are liars. So Euclid could be a truth teller and a mathematician, and he's just talking about the other mathematicians who are liars. Now, let's do this. What happens now? This completely changes the equation. Okay, this is now we are understanding why that alien puzzle that I asked you is so complicated, because it builds up on these levels of thinking where you keep on creating confusion. So now Euclid said that all mathematicians are liars, but Euclid says that he's a mathematician. Now we don't know whether he's actually telling the truth or not. Let's try to investigate. The first scenario is that Euclid is a truth teller. If Euclid is a truth teller, then the fact that he is saying that he's a mathematician will be true. And also the statement that all mathematicians are liars will also be true, which means then he has to be a liar. So then it breaks the argument completely. Let us see what happens if Euclid is a liar. If Euclid is a liar, then the fact that he's saying that he's a mathematician is a lie, which means he is not a mathematician. Okay. So the fact that he's saying that all mathematicians are liars could also be wrong. So we are fine with Euclid being a liar. So even in this situation, although it looks a little bit more complicated, the solution is that Euclid is still a liar. Now, the final blow here. What happens now? Let's think about this for a second. Euclid says all liars are mathematicians. All liars are mathematicians. And then Euclid says that he is a mathematician. If he's telling the truth, then he has to be a mathematician. But does that necessarily mean that he has to be a liar? Let's leave it at that, but let's look at the second situation where we say that Euclid is a liar. So then the fact that Euclid is a mathematician is wrong, because he's a liar, so he's not a mathematician. But then he's saying that all liars are mathematicians, which means then he has to be a mathematician, which creates a problem. But since he is lying, that statement itself is wrong. That all liars are mathematicians, because that itself could be wrong, because he's a liar. We don't care what he's saying. Everything that he's saying is wrong. He's not a mathematician, and all liars are also not mathematicians. So in this particular situation, Euclid could be a truth teller and he could be a liar, and both the times it makes sense, because if he's a truth teller, he's saying that all liars are mathematicians, but he's not saying that all mathematicians are liars. So he could still be a mathematician who is telling the truth, and he could still be a truth teller who is confessing that he himself is a mathematician. So in this particular situation, Euclid can be a truth teller and a liar, and both those sentences can still be true. Right? So this is the paradox. I mean, you cannot really predict what he is. He could be both. Actually, it's not a paradox, because in this situation where I gave you the puzzle that this sentence is false, The problem is because the sentence is neither true nor false. It cannot be both of them. But in this case, Euclid could actually be both of them. He could be a truth teller, he could be a liar. He can be both. So it's not actually a paradox. It has both the solutions possible. Okay, so now that we are equipped with all the tools, we will discuss more about this later. Definitely, these are very interesting things to talk about. But I first wanted to start the quiz because in the last class we started a little late, and I don't know if some people were a little, finding it hard to finish it off. So now I'm going to start it a little bit early, and we can discuss about the answers of the quiz, and we can do the poll, and we have a lot of time to do all those things. So you can take as much time as you want, but I expect you to take about 15 to 20 minutes. It's not that hard. And if you have any questions, you can message it to me privately. And let us start the quiz. And I'm going to stop the recording here after showing the questions so that whoever is watching the recording can actually look at the questions later. So there are about 3 questions in this quiz. The first question is which of the following is or true? So in this case, it's not a multiple choice question. You could actually have many possible answers which are actually true or many possible answers which are false. So you have to study each case separately and decide whether it's true or not. It's to do with the truth tables and the input. So the first one is input 1 and input 0, and the condition is OR, which means it is 1 or 0, and the output is 0. So you have to say if this entire thing is true or false. The second thing is input 0, 0. The condition is and the output is 0. You have to decide if this is true or false. The third one is that input is 1. The condition is not, and the output is 1. And the fourth one is that input is 1, 1, and the condition is OR, and the output is 1. So you have to decide if each of the situations is actually true or false. Now, I don't want any of you to type the answers to me. Just write it on a piece of paper, and then I will reveal the answers later, and then you can self-check your answers. Now, the second question is, for each situation, mention if they can be accommodated in Hilbert's Hotel. So we did discuss about Hilbert's Hotel in the last class. So we are going to see if each of the situations can be accommodated. The first situation is a bus with infinite guests. Okay. The second one is infinite buses with each having infinite guests. Third situation is infinite new guests where number of guests is the same as the number of real numbers. Okay. So when I say that the number of guests is the same as the number of real numbers, we can say that for every real number that exists, there is a guest to match that real number. So you can think of it that way, and you have to say if the first situation is possible, the second is possible, the third is possible. You have to decide which of them. More than one could be possible, right? So it's not a multiple choice question. None of the questions here are multiple choice. Each has a separate weightage. So let's say this is for 8 points. This is for 6 points. And the last one is for, I think I have one more, no, just 2. So we have 14, and we can say this is for 6 points. Okay, so in this case, you have to decide if each of these arguments is valid or not. The first argument is Socrates is a philosopher. All philosophers like thinking, so Socrates likes thinking. That's the first one. And the second one is I wash the dishes or I don't eat. I eat, thus I wash the dishes. This is the second question. I don't know if the things could be a little confusing, but I'm pretty sure if you think deep enough, you'll get answers to that. Okay, so I'm going to reduce the font a little bit so that all the questions can be visible at the same time. Okay, so now it is looking good. And let's start. Thank you.